Okay. So let me do an example. I'll send you guys an email of a simple example real quick. Let's do a cube. Sure. All right, let's see what happens. You guys take a minute. See if you can do long division on this bad boy. I made it nice. Nothing's missing, right? So you don't have to put a zeros of anything. All right, so let me see. You guys doing all right? I have no idea how it's coming out. The numbers could get gross, I don't know. Let me catch up to you a little bit. So what did you guys put here? Uh-oh.
Oh, you get this.
So you get x cubed.
Negative 3x squared.
And then you
Change the sign.
change the signs. That is a remarkably easy thing to forget. You got to tell you, so that's the subtraction step. You always subtract whatever you get. So this is subtracting this from that. So I get nothing there, and here I get
Negative x squared
negative.
plus 5x minus 2.
Yeah, you could bring the 2 down, but you don't have to. Yeah, just like we do with normal things.
It's going to be there anyway.
Yeah, it would be the thing that comes out next. Yeah, but you can bring it down. It wouldn't affect anything, really. X times what? What do I put here?
Negative x.
Good. Negative to make a negative, x to get one more x. So I get negative x squared
3x.
plus 3x. I like it. And then you
Change the sign.
change the sign. Sorry, let me stop for a second. You see, the minute, I mean, how much you have to remember that? What makes this, write it, change the signs. What makes this, write it, I mean, the minute you get that, I don't care how long I make this, you just keep doing that over and over and over.
We sure work to you on it. Doesn't matter where the top is set. For example, when
Oh, if you put that over there,
yeah,
that's fine. I like it. Here it's not as important. With numbers, it's kind of important where you put them. So you get things lined up, especially if there's decimals and all kind of stuff. Variables, it almost doesn't matter because you're ending, you know when you're done. Yes?
Can you finish this one?
Totally. So then you get, those go away, you get 2x
Minus 2.
minus 2. So plus 2, right? So then 2x minus 6. Change the signs. 4.
When we solve this kind of equations, it's impossible to have x squared and then x and then another x. So when we end up with that x, we got
Oh, what?
so x squared minus x, just to make sure we are on the correct path. It's impossible to get another x.
Yeah. It's basically impossible unless you wrote this with extra pieces to it. Yeah. Which hopefully you won't do. Okay. Alright. So, here's synthetic division. Here's what it looks like. And this is unbelievably cool. Let's take a second. Let me make sure you understand the motivation. Why was this a 1? And I just erased the damn thing, but oh well. Like this one, what would I put here? What would go here? 4. Why is it a 4? Why is that a 1? Why was the thing over here a 3? That first number is always going to be what that number is, right? Especially because synthetic division has to be divided by 1x plus something or 1x minus something. So since this is 1, whatever that number is, it's going to be part of the answer. All right, that's one piece I want to make clear. That shows up in synthetic. Also, I keep changing the damn sign. So if there was only a way to change the sign once at the beginning, I would do that, so then I wouldn't forget. Does that make sense? Because this is really easy to forget to change the sign here. So if only I could do that somewhere at the beginning. Like here, I could have made this negative x plus 3 and somehow mess with that. That gets a little bit weird, but with synthetic division, I can do it. Thank God. All right. Plus, let's see. All that really, where did this negative 1 come from? Because of this here, right? And that came from these two numbers. So the numbers are all that matters. As long as everything's in order, I could just look at the numbers. So that's the whole purpose of synthetic division. So here's what this would look like. What synthetic division says is write down the coefficients of the problem. So what's the coefficients of the top here? 1.
Negative 4.
Negative 4.
5.
5. Negative 2. And if I was missing something, I would just put a 0 there. Alright. Now, I don't like hockey. Sorry if you do. I don't watch it. But I do like to say it. There's a little penalty box over here. And in the little penalty box, what we're going to put, see how that 3 is kind of important? It's kind of messing with all this stuff. But here's where I can change the sign. So instead of putting negative 3, I'm going to put 3. So that's effectively changing the sign first instead of changing the sign every damn time. Because watch, where did this, where you got it, Jeff? You can do it. Where did this 6 come from? 2 times 3, right? So that was a plus 3. I would have gotten plus 6. I would not have had to change the sign. Where did this negative 3 come from? These two, right? If that would have been a plus 3, it would have been negative 3 right at the beginning. Let me stop there for a second. Yes?
So if it was x plus 3, we could have changed it to negative.
You would totally change it. So it's really whatever makes this 0. But you really just change the sign on the number. I like it. Let me stop there for a second. Once you see this start, it's going to be a little weird, obviously, if it's brand new to you. But you'll start to see all the same things that happened there will happen much quicker over here. I love this. The minute I was shown this, I'm like, why didn't you show this to me earlier? Yes?
So online, it's on my math lab, it's the appendix, or what is it on the, like, what section is it?
It's in the appendix, AP 27.
Okay.
Yeah. So in the back of the book, they actually number the appendix pages.
Okay.
Yeah. Not the very back, I can't remember, somewhere in there. Alright, so here, you ready? So this is what I meant earlier. Where'd that 1 come from? There, right? And that's always, if that would have been a 4, that would have been a 4, and the answer would have had a 4 in it, right? I really want this to make sense. That's why I just, whatever that is, I just bring it right down. This is going to be the answer down here. The answer is coefficients. So this is the problem's coefficients. So what I'm going to end up with down here are the answers coefficients. And some of you guys are like, but once you get used to this, it's remarkably beautiful. It's awesome. You know, like, you're a math dude. Of course you would say that. No, I'm just thinking. So now, again, remember, where did this 3 come from? 3 times 1, right? So whatever number you put there, you immediately multiply it and put the answer. So 3 times 1 is 3. And then you add. Look, where am I adding the problem? Negative 4 plus 3. Isn't that right there? Negative 4 plus 3? Negative 4 plus 3 is? Negative 1. Multiply. Where am I at the problem? Right there. 5 minus 3. You guys see it? Did you see it? Alright. Did you see it? And then 3 times 2? 6. Add. Positive 4. That's my remainder, right? Now, what was this the coefficient of? X to the third. I divided by x, so the power is going to go down to x squared. The answer will always be 1 degree less. So what's my answer going to be? 1x squared minus 1x plus 2 plus 4 over x minus 3. The same. damn thing. Now, isn't that a hell of a lot better than that shit? And it captures the important parts of that. Yes, ma'am?
You know, last time is always the remainder, right?
Always. So that's a 0. That's a really neat place to be, because that means that that went in evenly. So that's a way to factor it. That would be the next level of this. All right. So let's do this. You guys, you want to do the break first, and then we'll do like a little worksheet on this? I think that might be a good time to take a break. All right. I'm going to make an executive decision. We're going to do that. So here's what's going to happen. Anything you don't want to have possibly taken away from you, you want to take with you, because they can't lock the door. Right?